Hello, my students. Hello, everyone. Hoping you're doing well and everything. Staying safe at home. You're so much missed. So, let's have a quick revision on the stoichiometry. Our revision will include multiple choice questions, short answer, and extended response questions. Let's have a try. And stoichiometry chemists are mainly concerned with the types of bonds found in compounds, mass relationships in a chemical reaction, energy changes occurring in the chemical reactions, the speed with which chemical reactions occur. Yes, mass relationships in chemical reactions. That's why we study stoichiometry. Assume ideal stoichiometry in the reaction CH4 plus 2O2 resulting carbon dioxide plus 2H2O. If you know the mass of CH4, you can calculate only the mass of CO2 produced, only the mass of O2 reacting, only the mass of CO2 and H2O produced, the mass of O2 reacting, and CO2 plus H2O produced. Yes, you can calculate the mass of oxygen reacting with carbon dioxide and water produced, which mole ratio for the equation 6Li plus N2 resulting 2Li3N is incorrect. Perfect. 6 mole of Li over 2 moles of N2 because the correct ratio is 6 over 1. 6 lithium moles reacting with 1 nitrogen mole resulting 2 moles of lithium nitride. For the reaction below, how many moles of nitrogen are required to produce 18 mole of ammonia NH3? Okay, only 1 mole of N2 can produce 2 moles of NH3. So X moles of N2 producing 18 moles of NH3. By cross multiplication, we got 9 moles. What mass of NaCl can be produced by the reaction of 0.75 mole Cl2, the chlorine? Knowing that sodium 23, chlorine is 35.5. Let's have a try. 2 moles of sodium, 1 mole of chlorine, resulting 2 moles of sodium chloride. Then 0.7 mole, resulting X moles. Then calculating the mass, you will get 88 gram. What mass of carbon dioxide can be produced from 25 gram CaCO3, giving the decomposition reaction? CaCO3 decomposes into CaO plus CO2. Keeping in mind that this equation is chemically balanced. Okay, 25 gram of CaCO3, the calcium is 40, carbon is 12, oxygen 16. Okay, yes, 11 gram. If a chemical reaction involving substances A and B stops when B is completely used up, then B is referred to as the limiting reactant. It is the reactant which is completely consumed or used up in a chemical reaction. The next one. If a chemist calculates the maximum amount of product that could be obtained in a chemical reaction, he or she is calculating the theoretical yield, not the actual one. Okay? What is the maximum number of moles of AlCl3 that can be produced from 5 mole Al and 6 mole Cl2? We can find the chemically balanced equation as follows. 2 moles of aluminium reacting with 3 moles of chlorine, resulting 2 moles of aluminium chloride. So 5 moles of Al and 6 moles of Cl2, resulting 4 moles of AlCl3. It is the double of the quantity. Short answer. Why is the balanced equation necessary for solving a mass-mass stoichiometry problem? Because the coefficients of the balanced equation are needed for the mole-mole ratio that is necessary to solve stoichiometric problems involving two different substances. That's why we use the mass-mass stoichiometry problem to resolve the mole-mole ratio using the balanced equation. What data are necessary to calculate the percentage yield of a reaction? Of course, the theoretical and the actual. A student makes a compound in the laboratory and reports an actual yield of 120%. Is this result possible, assuming that all masses were measured correctly, giving an explanation? The product was impure, so the mass contained of the product and other substances. For example, if NaCl is made from HCl and NaOH but is not dried, the mass of NaCl can include water, which would result in a yield greater than the 100%. That was all for today. Thank you. Keep in touch, keep in contact with your LMS, and goodbye.